Hi everyone, in this lesson video we're going to be learning about section 4.7, the quadratic formula. Our objectives are that we can solve the quadratic equations using the quadratic formula, as well as we can determine the number of solutions by using the discriminant. So when I say solve a quadratic equation, that means we're looking for the solutions, which are also called the zeros. They're also called the roots, and basically all of those words just mean where the parabola crosses the x-axis. The reason why they're called zeros is because when the parabola intersects the x-axis, the y value of each of those coordinates is 0. You will see in this lesson that the quadratic formula is very helpful in determining what the solutions are of a quadratic equation. If you are interested in seeing how the quadratic formula is derived from the standard form of a quadratic equation, feel free to check out page 240 to see how this is made. So here's the equation, the quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully that sounds a little bit familiar from Algebra 1. So once you are given a quadratic equation, you want to put it in standard form and then identify what your a, b, and c values are, and then from there just substitute those a, b, c values in for the quadratic formula. So I'm about to show you how that works. So like I said, make sure your quadratic is in standard form. That means ax squared plus bx plus c, and it has to equal 0 because that's what we're looking for, are the values of x when y equals 0. So let's take a look at example 1, part A. We're given the quadratic 2x squared minus x equals 4. We need to find the solutions using the quadratic formula. So you may have noticed that there is not a 0 on the right side, so it's currently not in standard form. So what we want to do is subtract 4 from both sides so that we do get a 0 on the right side. So that means we have 2x squared minus 1x minus 4 equals 0. From there we can identify what our a, b, and c values are. So a is 2, b is negative 1, and c is negative 4. From there we're going to be using the quadratic formula to find our solutions. So I'm going to write the general quadratic formula first so we can work from there. Okay, so we're taking our b value, so we have negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4, all over 2 times 2. From there, we want to figure out what is that expression inside the square root. Find out that we have positive 33 under the radical. So we have 1 plus or minus the square root of 33, all divided by 4. We cannot reduce the square root of 33 because there are no perfect square factors of 33 besides 1. And so we can just rewrite this as x equals 1 plus square root of 33 over 4, or x is equal to 1 minus the square root of 33 over 4. So that plus or minus symbol right there just means that there's two solutions, one with a plus sign and one with a minus sign. So these would be the solutions or the zeros of this quadratic. I'd like to remind you of how you can check to make sure you got the correct zeros. So I'm going to show you the calculator process that we did talk about in a previous lesson video. So I wrote right below our two solutions, I wrote the decimal equivalent, and I did have to round a little bit because the square root of 33 is a long decimal. So I have my two solutions there, and now I want to make sure that I'm getting the same solutions when I'm graphing. So take a moment, pull out your graphing calculator, turn it on, and type in the standard form of the quadratic equation that we're given, 2x squared minus 1x minus 4, which is what we started with in the beginning after we subtracted 4. So once you get to that point, now you want to go to trace. And if your window is currently not showing your parabola, you do want to change it up a little bit. These are the window constraints that I have currently, so negative 20 and positive 20. Technically, we could zoom in a little bit more, but this is fine. So now we have our quadratic equation or parabola graphed. So to go find the zeros, we want to go to Second Calc, which is the same window that we use for minimum and maximums. You want to go down to 0, press enter, and then now you want to choose a point above the axis and below the axis. and press enter 3 times total. And you can see right there that we do have the first zero. Actually, it's the second one, but the order doesn't matter. So we do get negative 1.186 for one of the zeros. And that's the zero that we found down here. Now I'm going to do the same process for the other zero. So go back to second calc, go down to 0, and choose a point on the bottom of the parabola, and then choose one above the x-axis. And there you have it. We have our other zero, which is 1.686. So our calculator is confirming that our work is correct. In part B, we're given the quadratic x squared plus 6x plus 9 equals 0. And I put a 1 in front just to make sure it's obvious that the a value is 1. So now we know the a is 1, the b is 6, and the c is 9. And we can go straight to our ABCs because the quadratic is already in standard form. We have a 0 on the right side. So what we're going to do now is use the quadratic formula once again. Negative b plus or minus square root of b squared minus 4ac all over 2a. So now substituting in our given values for ABC, we have negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 9 all over 2 times 1. When you simplify the expression under the radical, you get 6 squared, which is 36. 36 minus 36 is 0. So we technically have negative 6 plus or minus the square root of 0 all over 2. Well, you know that the square root of 0 is just 0. So essentially we have negative 6 plus or minus 0 divided by 2. Well, usually we get two solutions, but in this case, when we're adding or subtracting 0, that doesn't change our answer. So we're really only getting one solution here. So we have negative 6 over 2, and that equals negative 3. So our solution for this quadratic is negative 3. I'd like to take a moment to show you visually what's going on in part A and part B. So we just saw this quadratic graph on our calculator, and we found out the two solutions. They were these approximate solutions right here. In visual for the graph, we have a parabola opening up and it's intersecting at 2 points. So that means we have two solutions or two zeros. For part B, we only have one solution. So that means that the parabola is only touching the x-axis at the vertex of that parabola. So something like that. And that typically happens when you have a perfect square trinomial. So if we were to factor this perfect square trinomial, we would get x plus 3 times x plus 3, which is just x plus 3 squared. And when you solve that, you just get x equals negative 3. So in this particular situation, factoring would have been the faster way to go. But the quadratic formula is always reliable when you are solving for the zeros. So there's a visual of what's going on. In example 2, we are about to solve a real-world problem by applying the quadratic formula to a quadratic model. And this is the first example where you're going to see that the a value is going to be negative. It says, your school's jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. The equation P equals negative x squared plus 48x minus 300 models the profit of the fundraiser. What is the least amount in dollars you can charge for a CD to make a profit of $200? So we're given the quadratic equation, and you notice that the a value is negative 1. So we're going to be plugging in our ideal profit of $200. So that's going to be substituted in for the P. In order to get this quadratic in standard form and get 0 on one side of the equation, we want to subtract 200 from both sides. From here, we can identify our a, b, and c values. Now that we know that our a value is negative 1, b is 48, and c is negative 500, we can use the quadratic formula just like in the previous example to find out the solutions. So now that I have my basic quadratic formula set up, I can now substitute in my ABC values. So instead of putting a negative b there, I'm going to put a negative 48 plus or minus 48 squared minus 4 times negative 1 times negative 500. So hopefully you're realizing that the signs in front are going with the numbers. And on the bottom we have 2 times negative 1. So now let's figure out what is under the radical. When multiplying and combining, I find out that the number 304 is under the radical. Now we want to find an approximate solution for when we use the plus sign as well as the negative sign. We find out first solution, that x is approximately equal to 15.282. For the second solution, you can just copy what you had originally, so second entry, and then just go over to the plus sign and make it a minus sign. We find out that the other solution is approximately 32.717. So that means our two possible selling prices for the CDs are either $15.82 or $32.72. So you may be wondering, does it make sense that two different prices can yield the same profit? It should make sense to you because you can generate a given profit either by selling many CDs at a low price, which would be this lower price over here, $15.82, or less CDs at a higher price, which would be the $32.72. So the question asked in the beginning, what is the least amount in dollars you can charge for a CD to make a profit of $200? So out of the two possible solutions, the lower amount is $15.82. So that is our answer for this problem. So now that we've had the opportunity to practice using the quadratic formula a couple times, let's talk about another application of using the quadratic formula, and that's called the discriminant. The discriminant of a quadratic equation is the expression underneath the radical. So b squared minus 4ac is called the discriminant. B squared minus 4ac is the discriminant. Now, if you find out that this value is greater than 0, aka a positive number, you will get two real solutions. So you can see in these two graphs at right that we have a solution here as well as here, and the other graph we have a solution here and here. So each of those parabolas have two intersection points or two x-intercepts in each graph. So one more time, if the discriminant is greater than 0 or a positive number, you will have two real solutions. If the discriminant b squared minus 4ac is equal to 0, which means the number under the radical is 0, you will get one real solution. And that means when the parabola is intersecting the x-axis, it's only intersecting at the vertex. So there's only one real solution in each of those graphs, one x-intercept. The last possibility is if the discriminant b squared minus 4ac is less than 0, aka that number is a negative number. If this is the situation, that means we have a negative under the radical. And currently, we don't know what to do with negatives under the radical. We're actually going to learn about that in the next video, section 4.8. But as of now, there are no real solutions. So that means the parabola is not going to intersect the x-axis at all visually. So you can see in both of these parabolas, they do not cross the x-axis. That means there are no x-intercepts and no real solutions. So these are the three possibilities when working with a discriminant. In example 3, we're given the quadratic negative 2x squared minus 3x plus 5 equals 0. So first thing I notice is that we already have it in standard form and it already equals 0. So that means we don't have to move anything over from the other side. So next thing I want to do is identify what the a, b, and c values are. So as always, I always write a, b, c below the standard form. So that means we know a is equal to negative 2, b is equal to negative 3, and c is equal to positive 5. Now we're just going to be using the discriminant, which is b squared minus 4ac, to figure out what that equals, and that will help us figure out how many solutions or how many real solutions there are. So b squared minus 4ac, now let's plug in the a, b, c values. So we're taking negative 3 and we're squaring it. Make sure you use parentheses around negatives especially. And we're subtracting 4 times negative 2 times 5. So when we simplify that, we get 9 plus 8 times 5 is 40. So that means we get 49 for our discriminant. Because the discriminant is positive, that means it's greater than 0. So that means our equation has two real solutions. So that means this parabola crosses the x-axis at 2 points or 2 coordinates. If we find out that the discriminant is equal to 0, that means we only have one real solution. That would be another possibility in another situation. Or if we found that the discriminant was negative, that means there would be no real solutions. In example 4, we're about to use a discriminant to solve a real-world problem, and particularly this is kind of like a physics math problem. So it says you hit a golf ball into the air from a height of 1 inch above the ground with an initial vertical velocity of 85 feet per second. The function h equals negative 16t squared plus 85t plus 1/12 models the height in feet of the ball at time t in seconds. Will the ball reach a height of 115 feet? So before you go straight into the quadratic formula, we actually just need to use the discriminant here because we only need to know whether a real solution exists, not its actual value. So the question at the end just said, will the ball reach a height of 115 feet, not at what time will the ball reach a height of 115 feet. So here is the standard form that we're given. And what we want to do, since we're trying to find whether or not the ball will reach 115 feet, we're going to replace the h with 115. So just like the previous problems, we want to make sure that the quadratic is in standard form before doing the discriminant. So we want to get 0 on one side of the equation. So that means we want to subtract 115 from both sides. So when looking at this 1/12, I noticed that this fraction in decimal form is a repeating fraction or decimal. We do not want to round here because we want to get an exact solution. So that means we're going to have to keep it in fraction form. So what I'm doing here is I'm doing 1/12 minus 115, and it's going to give me this in decimal. We don't want to deal with decimals because of the nature of the number. So we have this decimal now. So now go to math and then fraction, enter, and it gives me this number in improper fraction form. So that is the form of this number that I'm going to be using. So now that I identified my a, b, and c values, I can easily substitute these values in for the discriminant expression. So that means we're taking 85 and we're squaring it and subtracting 4 times negative 16 times negative 1,379 over 12. Now let's go to our calculator to figure out what that equals. And to paste this fraction, we can actually just do second answer here. So we don't have to retype the fraction. Let's see what it equals. So again, we're getting a repeating decimal, so I want to go back to math. And now I'm getting negative 389 over 3, and I'll put that in mixed form in a second. The mixed fraction form is negative 129 and 2/3. So no matter the form, we know that this number, this discriminant value, is a negative number. So it's less than 0, which means there are no real solutions. So because the discriminant is negative, that means the equation 115 equals negative 16t squared plus 85t plus 1/12 has no real solutions. Therefore, the golf ball will not reach a height of 115 feet. So now that we know that the golf ball will not reach a height of 115 feet, I do want to talk about the other two possibilities. What if the discriminant was equal to 0? Well, if the discriminant was equal to 0, the golf ball would hit 115 feet once at its max point. What if the discriminant was greater than 0? Well, if the discriminant was a positive number, then the golf ball would have hit the height of 115 feet twice. So those are the three possibilities for this given situation. That completes this lesson. Please write down these 7 lesson check problems and try all of them, and let me know if you have any questions on how to use the quadratic formula or the discriminant the next time we meet.